doing today is looking at composite functions. So a composite function is written as f bracket g bracket x of x, and how we say that is f of g of x. So f of g of x. And it's a combination of two or more functions, which is also known as a function of a function, where the output of one function, g of x, becomes the input of the second function. So the input values of a composite function go through a double function. So how we do this is we want to find the composite function f of g of x, given that we have f of x is x squared and g of x is 2x minus 5. So f of g of x is the same as f of our g of x function is 2x minus 5. So 2x minus 5. Now, when we have something inside those brackets, that's what we're substituting into our f function. So where we have an x in our f of x function, we are going to replace that x. So we're going to be replacing that x from our x squared with our 2x minus 5. So that means what we're going to have is 2x minus 5 all squared. Now we can simplify that through expansion. So we get 4x squared minus 20x plus 25, because we have that it was a minus b all squared, which is a squared, minus 2ab plus b squared, which is our perfect square. Okay, so that is how we find our f of g of x. Right, this can be tricky, so we need to make sure that we're listening and we're paying attention. With b, we again want to find f of g of x. This time our function f of x, Blake, is x cubed. And our function g of x is x squared plus 3. So what we will have is f of x squared plus 3. What that means, wherever we have an x in our f of x, we're going to replace that with our g of x squared plus 3, resulting in us having x squared plus 3 all cubed. Now, when we have anything to a higher power than 2, I wouldn't bother expanding it unless it asks for it to be expanded and simplified. Okay, looking at C, what we have is f of x is equal to 5x minus 3. G of x is x cubed plus 2. So we are finding f of g of x. What we need to do is we need to replace our g of x with our x cubed plus 2. So we will have f of x cubed plus 2. That means wherever we have an x in our function f of x, we are going to replace that with our x cubed plus 2. So what that means is we'll have 5 lots of x cubed plus 2 and then our minus 3 at the end there. Okay. What this results in is we can expand it to get 5x cubed plus 10 minus 3, and I really should have given you another line because we can collect like terms to get 5x cubed plus 7. Okay. Now with example 2, what we have is f of x equals 5x plus 2, g of x equals 1 on x. So what we want to find for A is we want to find f of g of x. So again, we're going to replace our g of x with the function 1 on x. So what that means is we'll have f of g of x is equal to f of 1 over x. So where we have an x in our function f of x, we're replacing that with a 1 over x. This means that we will have 5 lots of 1 over x plus 2 Now, when we expand 5 lots of 1 over x, we get that f of g of x is then equal to 5 over x plus our 2. Because 5 times 1 over x is just 5 over x. Now, what we've been asked to do for part B is we've been asked to find f of g of 10 for these functions. So we already know that f of g of x is equal to 5 over x plus our 2. And to find f of g of 10, what we are doing is we're replacing our x with a 10. So we'll get 5 over 10 plus 2. Now 5 over 10 is just equal to half, and a half plus 2 is 2.5 or 2.5. So we're actually finding a value there when our x is replaced with a number. Okay, now what we want to do for C is we want to find g of f of x. So this is slightly a little bit different. So what we have is we want to find g of f of x. So it's just the swap spots, okay? So what this means is we will be replacing our f of x with 5x plus 2. So we will have g of 5x plus 2, meaning that we will replace our x in our g of x with 5x plus 2. So this will equal our g of f of x will equal, instead of 1 over x, it will be 1 over 5x plus 2. Okay, and then to find g of f of negative 4, well, we know that g of f of x is equal to 1 over 5x plus 2. So g, stay still, g of f of negative 4 is equal to 1 over 5 lots of negative 4 plus 2. We can just put that into our calculator to get our answer, and we get negative 1 over 18 when we calculate that. Okay, so this is just a big exercise on substitution pretty much with functions. All right, the last example here before you have a go independently is we want to find the domain and range of f of g of x, given that f of x equals the square root of x and g of x equals 9 minus x squared. So we have f of g of x. What that is going to be is f of our g of x is our 9 minus x squared. So f of 9 minus x squared. So what we are doing is we're replacing our x in our f of x with 9 minus x squared. So that means this is going to be the square root of 9 minus x squared. Ooh, this is exciting. Does anyone recognise this function? Yeah? It's a semicircle. This is a semicircle. This is what we looked at yesterday. Okay, it's a semicircle in the form y equals the square root of r squared minus x squared. Okay, so if we were to, because we found our function, we found f of g of x, but the question is asking us to find our domain and our range, okay? So we're making sure that we're reading our question, we're answering all the bits and pieces. So we might need to do a little tiny sketch of our semicircle. Is my semicircle above or below my x-axis, or is it to the left or the right of my y-axis? It's above our y-axis, okay? So it's our general, and it's going up and over as a semicircle, or as best as you can draw your semicircle. Okay, what is my radius of this semicircle going to be? 3. So we're going to have that it goes from minus 3 to 3 and it goes up to 3 on our y-axis. So remember, our domain is all about our x values. So our domain, the x values of this semicircle is negative 3 to 3. Our range of our semicircle is the y values, which is 0 to 3.